Assalamu alaikum wa rahmatullah. In today's lecture, we are going to discuss the current through different conductors in a circuit. Up to now, we have discussed how to calculate the current through different resistors within a circuit, whether the resistors are in series or in parallel. But there are cases at times when we have to calculate the current through different conductor limbs. So let's take a problem and understand what we mean by this calculation of the current through different conductors. This topic is very important as far as the JEE is concerned. For example, if we start with this problem, if we have three resistances, maybe this one is 4 ohm, this one is 3 ohm, and this one is 6 ohm. And the value of this it is 4 volt battery. If we want to find the current through different resistances, since they are in series, the current will be same. We can find the current. How to do it? It is simple: 4 plus 3 plus 6, 13 ohms resistance, 4 volt battery, and we can do it. But let's suppose we connect these 2 points like this and these 2 points like this. And if I ask you to find the current through this conductor, now you would start saying, for example, this is at 0 volt and this will be at 4 volt. If this is at 4 volt, this point will also be at 4 volt. If this point is at 0 volts, this point will also be at 0 volt. So it's like this. Fine. Now, one of the misconceptions that at times the student can say tames is that the current through this conductor will be 0. And whenever such questions are asked in JEE, whether in main or in advanced, they give you the first choice they give you is the 0 ampere, and then there are other options. And most of the students think that 0 is the answer. And they go by this logic that this point is at some potential. Right now it is at 4 volt, and this point is also at 4 volt. Since both the points are at same potential, there will be no current through this conductor. And where from did they get this idea? They get it from Ohm's law. Since Ohm's law says that the current flowing through any resistor is equal to potential difference divided by the resistance value. So what they do, they say the potential difference between these 2 points is 0. Since there is no potential difference, there will be no current. So they go by this logic. But there is a problem in while using that logic. Where the problem starts, this is a pure conductor. And in conductor, we can say the resistance tends to 0. When we say resistance tends to 0, let's take an example of a resistor. For example, this point is at potential X and a current I is flowing through this resistor. The potential at this point will be X minus IR. What if this R tends to 0? That is in case of a conductor. In conductors, this resistance value tends to 0. Ideally, it is never 0. We cannot say that the resistance of a conductor is 0 actually. But it is so, you can say, low, the resistance value is so low that we can say that it tends to 0. So when this resistance value tends to 0, it means the value of this IR will be almost equal to 0. It means if this point, the left one, now this resistance, when R tends to 0, this will no longer be a resistance, it will almost be a conductor. And the value of potential here, if the value is X, the potential at this point will again be X. Now see, the potential at the one end of the conductor is same at the other end of the conductor. That's why we say, while we connect any 2 points using any conductor, we say that the potential of these 2 points is same. Fine. So the current through this conductor is not 0. But how to find the value of this current? So let's first try to find out the net current flowing through this conductor. So you can note it down this point, or at least you have to make sure that you know it, you understand it. These are the answers. Fine. So if this point is 4 volt, this is again 4. If this is 0, this is again 0. Now the 4 ohm resistance is between 0 and 4. 3 ohm is between 0 and 4. 6 ohm is between 4 and 0. So all these 3 resistances are in parallel. Since they are in parallel, what will be the net resistance value? You can find it out. 6 parallel 3, that is 2. 2 parallel 4, that is 4 by 3. So the resistance net value is 4 by 3 ohms. You can also try that 1 by R net equal to 1 by R1 plus 1 by R2 plus 1 by R3. You will get this value easily. Actually 6 parallel 3, that's 6 by 3, that is 2. And 4 parallel 2 is 4 by 3. This is the net value of the resistance of the circuit. And these 3 resistances physically seem to be in series, but actually they are not in series. They are in parallel. Now what will be the net current that will, you can say, will be generated, or rather that will flow through this part of the circuit? The current net will be potential difference by resistance, and potential difference is 4, resistance is 4 by 3, so this will be 3 amperes. So 3 amperes current will flow through this and will come like this, 3 amperes. Now from this point onwards, if we have an understanding of this conductor, and if we think that the current through this will be 0, then this 3 ampere will flow through this. Likewise, if the current flow through this conductor will be 0, it means 3 ampere will flow through this. Then same 3 ampere will flow through this. Means all these 3 are in series. But we have already discussed all these 3 are in parallel, because the potential of this point and this point is same. It means this current will get divided into 2 parts, not equal 2 parts, but surely a part of this current will flow through this conductor, and some of, you can say, a part of this current will flow through this 4 ohm resistor. Likewise through this, we don't know, there will be some current through this, and we don't know, we will find it out. Now how to find it out? It is very simple. We can use a junction law. For example, we know 3 ampere current is flowing towards this node. Fine. Now between these 2 points, what is the potential difference? It is 4 volt and 0 volt. It is 4 volt potential difference, and the resistance value is 4. So the higher potential side is this, lower is this. It means current will flow like this from left to right, and the value of current will be 4 over 4, that's 1 ampere. So 1 ampere rightwards. Now let's take this node. How much of current is flowing towards the node? That is 3 ampere. 3 ampere is flowing towards node. And what amount of the current is flowing away from the node? 1 ampere. What about the rest of the 2 amperes? Surely that 2 ampere will flow through this. So we got the answer. The current through this conductor is 2 ampere, and it's not 0. So possibly second option will be 2 ampere. This one is wrong. Let's try to find out the current through the second conductor. Again 3 ampere current is, you can say, entering the circuit and 3 ampere will be leaving. So it means some of these two have to be 3 ampere, or we can use this node now. What is the potential difference across the 6 ohm resistor? That is 4 and 0, that is 4 volt. What will be the current from higher to lower, means left to right, and how much? 4 by 6, that is 2 by 3 ampere. So 2 by 3 ampere is coming from this side. 3 ampere is, you can say, 3 ampere of the current is exiting this node. What will be the amount of current that will flow towards the node through this? It is very simple. Net amount of the current flowing towards the node has to be equal to the amount of the current flowing away from the node. So this, for example, whatever this is I value, so I plus 2 by 3 has to be 3. So I will be equal to simply 3 minus 2 by 3, that is 7 by 3 amperes. 7 by 3 amperes. So we got the answer. So the second is 7 by 3 amperes. So what we learned from this problem is, at times we have to find the current through the different conductors. And point number 1, the current through these conductors will not be 0. Maybe at times it is 0, but we have to calculate it. It is not 0 because the potential difference between the, you can say, extreme 2 points is 0. It is not the case. Second point, very important, we have to find the net current and use the junction law to find out this current values through different conductor parts. Now let's try out one more question on this. For example, we have a question like this. Yes. Can we solve it? Yes, it's very easy. How? 12, 12, 24, 24 ohm, and this is 26, 24, 6, that's 30 ohm. 30 ohm parallel 24 ohm, and we can find the net resistance and the current. But let's suppose I am connecting these 2 points like this conductor, and I am asking you to find out the current through this conductor. Now what will happen when you can say connect these 2 points? See, this is 0 volt, this is 40 volt. Now this is 40, whatever the value, maybe this is X, then this is also X. At the first place, when there was no such, you can say, conductor connecting these 2 points, this 12 was in series with 12, and there was no, you can say, no way that this 12 can be in parallel with the 6, because the potential difference could never have been, you can say, the same. But now the potential difference between these 2 points is 40x. This is at 40 volt and this point is at X. This one is at 40 volt, this is X. So these 2 are in parallel right now. Now 12 parallel 6, so the resistance value will be 4. Then again these 2, X0, X0, again in parallel. So 24 parallel this will be 8. So the net value of will be 8 plus 4 is 12 ohm, and the value of current will be 40 over 12. So that is around 3.33, or we can say it is 10 by 3 amperes. So this much of current will flow through the circuit. So I can write it down, 10 by 3 amperes, and current leaving the circuit is 10 by 3 amperes. Again, you can say go with this logic that the potential difference across this is 0, so 0 current will flow. No, This is not a resistor, this is a simple conductor. There is no drop of the potential across this conductor. Actually, if we see very minutely, there is always a drop, but it is so negligible since the resistance of a conductor is very low that this X and this X, there will hardly be any potential difference. Anyway, let's try to find it out. How to find it out? First of all, we have 10 by 3 ampere current coming from this, you can see, branch. Now, it gets divided into two. 12 and 6 are in parallel, so 12 and 6. Now, how the distribution works, we know the ratio of the current through this and this. If this is I1, this is I2, so I1 is to I2 will be equal to 1 by 12 is to 1 by 6, that is equal to 1 is to 2. Obviously, this 12 ohm resistance provides more resistance to the current, so less current will flow through this, and this is half the value of 12, so double the current will flow through 6 ohm resistor. That we have already discussed. So 1 is to 2, it means we are going to make, you can see, break this current into 3 parts. One part will go through 12 ohm and 2 parts will go through 6 ohm. Now, what will be the value of this I1? So I1 will be equal to actually 1 by 3 into net current. It is 1/3 of the net current, because 1/3 of this net current flows through 12 ohm. So that will be equal to 10 by 9 ampere. So we can see the current flowing through this from positive, negative towards right. It is 10 by 9 ampere. What about this? It is double that. So it will be plus minus, and this will be 20 over 9 ampere. Simple. And what is this net current? 10 by 9 plus 20 by 9, that is 30 by 9, or we can say that is 10 by 3. That's here, net current. It gets distributed in 2 parts. What about this one? Now let's see this one. Here, this value is double the value of this 12. So, or we can say this is half the value of this resistance. So 10 by 3, when this 10 by 3, this branch is collecting the current from these two resistances, which on the other hand are in parallel. The current flowing through this, for example, it is I3 and this is I4. The ratio of I3 is to I4 will be equal to how much? More current will flow through this, because this is the value of the resistance is less, and since this resistance value is half the value of the opposite resistance that is in parallel, so double the current will flow through this. So ratio of these currents I3 is to I4 will be 2 is to 1. This one was 1 is to 2, because here we had this 12 ohm and half value was, you can see, at the bottom. Now in this case the ratio will be 2 is to 1. Now the value of I3 will be double part. So double means it will be 20 by this one, 9, this ampere, and here this will be 10 by 9 ampere. So we analyze this thing. Now let's try to find out the current through this. Actually, we don't need to solve both these, you can say, this resistances, but just to make sure that we learn how to do this, we did find the value of the currents through all the branches. Now the only branch pending is this one. Now let's try to analyze this node. What is the value of this current coming towards the node? That is 20 by 9. And what is the value of the current that has to go away from the node? Actually, coming is only this one, going, you can say, away from the node or exiting the node, that is 10 by 9 ampere from here, and rest of the value that will flow through this. So the value of the current flowing through this will be 20 by 9 minus 10 by 9, so that is 10 by 9 towards, you can say, upwards. Now let's see whether this, you can see, we can analyze this node, we can cross verify whether this answer is correct or not. 10 by 9 is coming from this side, 10 by 9 is coming from this side, so they get added, you can say they add up here, and the net value, that is 20 by 9 coming out of the node from here. This is 20 by 9, so we are done. So the answer is 10/9 amperes. So this is how we approach such problems. You can just note it down. Last time we did one question on the combination of the resistances. At that time we were, you can say, trying to find out the net resistance of the circuit between 2 points. Now we will try to find out the current through different conductor parts. Let's take the same example. It was like this. It was like this. "12-volt battery, and we have to find the current through this conductor." How to solve this problem? We did this problem, actually we solved this in last one of the lectures, where we were asked to find the resistance between these 2 points, net resistance. But again we will try to solve it. How to solve it? Simple thing is, we can just unfold this V part, this part, we can just turn it like this, so we will get something like this. So this is 4 and this is 4, just 4. So this point is connected to this. We can delete battery inside and we can connect it like this, 12 volt, and we can now delete this thing. Done. Now this looks very familiar and we have already solved such problems, but anyway, let's try to find out the current through this conductor connecting these 2 points. Again, if this point is at X potential, this will again be at X potential, right? Since we have you can say learned that the potential difference across this is 0, but still some current can flow through this conductor because this is a pure conductor. So the solution part A is 0 ampere, and in no way will this be the answer. We can have this, we can get this 0 ampere. We will discuss that special case when the current through this middle conductor, it can be 0. Actually it can be 0 in a lot of combinations, but we have to find it out. This current will not be 0 because of this potential difference issue. So that reasoning is wrong. But this can again be 0. For example, this is a kind of a Wheatstone bridge that we are going to study in next class, and if this is a balanced Wheatstone bridge, then the current through this in between conductor will be 0. But right now this is not 0 because of this reason. Fine, let's try to find it out. How? This is X, and this is value is 12, this is 0, means these two resistances are in parallel, potential difference is same, 12x, 12x. 4 for parallel is 2 ohm, 6 and 3 again in parallel, x0, x0. So 6 parallel 3, that is 2. 2 plus 2 is 4. 12-volt battery. So the current through resistor will be 12 by 4, that is 3 ampere. So the current through the circuit will be 3 amperes. What is the distribution of the current here? The two resistances are in parallel. The value of the resistance is same. The ratio will be 1 by 4 is to 1 by 4, that is 1 is to 1. So this will get divided into two parts. So this plus minus 1.5 ampere and 1.5 ampere. Fine. Now this current gets collected from these two, and these two are in parallel. So let's can say Forget this part of the circuit right now. Just look at this part. This branch is collecting current from two parallel resistances, and we know how to calculate it. This distribution will be same. Now the current through, for example, through this is I1, through this is I2. So I1 is to I2 will be 1 by 6 is to 1 by 3. That will be 1 is to 2. From here one part and from here two parts. Why? Because the resistance here is half that of this 6. The more current will flow through this. So we have to divide the current in three parts. What is the value of the net current? 3 ampere. So if we divide into three parts, that's 1 ampere. So one part will go through this. It means plus minus 1 ampere, and two parts will go through 3 ohm resistor. So plus minus, this is 2 ampere. Sorry. So 1 plus 2, that will become 3 and go done. From here 3 distributes into equal two parts because the resistance value is equal. So that is 1.5, 1.5. Now let's check this node. The current flowing towards this node is 1.5 amperes. And current going out of the node is 2 amperes. It means this node is getting 0.5 extra amperes from somewhere else. And what is the only path that this node can, you can say, receive some extra charge or get some current? That is this. So 0.5 ampere resistance is coming. So current is not moving towards, you can say, upwards, it is moving downwards. So the value of the current through this part is 0.5 amperes. So 1.5 plus 0.5, it is 2 amperes. Done. Now let's see this. 1.5 ampere is coming from this part. 1 ampere is going through 6 ohm resistor. And rest of the value, 1.5 minus 1, that is 0.5. That is going down here. And again, we have verified this. So the current through the conductor will be 0.5 amperes. We will go for one more question on this topic. Let's suppose we have a condition like this. Condition like this. So this is 2, 2, 2, 4, 4. Okay. Sorry. So this is 2 volt. And we have to find the current through this I1 and current through this I2. These two conductors, we have to find the current. Now, if this is the 2 volt battery, let's suppose this is 0 volt, then this will be 2 volt. If this is at 2, see, this conductor is connecting these 2 points. So this is again 2, this is again 2. If this is 0, this one is 0, again this one is 0. All these, they are the same actually points. This one, and this one. Now this is 0, this is 2. We cannot say if this is 0 and this is again 0, because there is a resistor and there will be some drop or some rise in the potential. So the conductor is connecting these 2 points. We can say these 2 points are at the same potential. Now let's try to find out the net current first of all. So this is between 0 and 2, 2 ohm, 0 and 2, 2 ohm, 0 and 2, 2 ohm, 2 and 0, 4 ohm, 2 and 0, this for 2 and 0, 4 ohm. So 4, 4, 2, 2, 2, all are in parallel. So we will have 2, 2, 2, 4, 4. This is the, you can say, situation. All the 5 resistors are in parallel. And what will be the value of the resistance? So 2 and 2 parallel will form 2. Then this 2 in parallel with this will form 1. These 2 in parallel will form 1. 1 and 1 parallel will form 0.5. So that is the net resistance value. 1 by 2 ohm. Net resistance value of the circuit. What will be the net current? Net current will be equal to net potential drop 2 divided by 1 by 2, that is 4 amperes. So 4 ampere current from here, 4 ampere coming here. Now from this point, maybe you start thinking that this current 4 ampere will get distributed in between these two. So 2 ampere will flow through this, 2 ampere through this. But that's, you can say there is a problem in that reasoning. Why? There is a third limb, and we don't know whether there is some current flowing through this limb or not. So right now we will suppose that there is some current flowing through this limb. Anyway, 4 amperes current is flowing towards the node. What about this part? This is at 0 volt, this is at 2 volt. Potential difference will be 2 volt, and this is at higher potential, so plus minus current will flow from left to right. The resistance value is 2, so 2 over 2 is 1 ampere. So 1 ampere of current will flow through this part. That we know for sure. Done. What about this part? Again, plus minus 1 ampere will flow through this. So see, 4 ampere of current is coming towards this node, out of which 1 ampere is going through one resistor, this 2 ohm resistor, then 1 ampere is going through this 2 ohm resistor. What is left there? Out of 4, 1 plus 1 is gone, the 2 amperes are left, so 2 amperes will flow through this. We got the answer. Through this the current is 2 ampere, but we don't know through what about the current through this. That we have to find out. We have to find out that. Now let's see this part of the circuit. This is a 2 volt, 0 volt, higher, lower, so plus minus current will flow from higher to lower through this resistor. How much current? 2 divided by 2, 1 ampere, so 1 ampere towards this node. So 1 ampere is, now let's take this node. 1 ampere is coming towards this, 1 ampere is coming towards this, so they will combine, form 2 amperes, so the current through this conductor will be 2 amperes. Now let's check this node. 2 amperes of the current flowing towards this node, 1 ampere from here, 2 plus 1 is 3, so 3 amperes. यहाँ से 3 एम्पियर जाएगी करंट. अच्छा, यहाँ पर इस नोड पे देखते हैं हम, तो ये वाली करंट तो दे रखी है, ये वी डोंट नो दिस वन एंड वी डोंट नो दिस वन. सो ये हमें वी कैन फाइंड इट आउट हाउ. 2 वोल्ट एक साइड पोटेंशियल, दूसरी साइड 0, सो ये हायर है, ये लोअर है. कितनी करंट चलेगी? पोटेंशियल डिफरेंस इज 2 डिवाइड बाय रेजिस्टेंस 4, 0.5 एम्पियर, 0.5 एम्पियर हो गया. सो 2 एम्पियर इज फ्लोइंग टुवर्ड्स दिस नोड, 0.5 उससे चली गई, तो वहाँ कितना बचा? 1.5 एम्पियर. वो आएगी जाएगी ऑब्वियसली. 2 एम्पियर्स इज कैन से एंटरिंग नोड में जो एंटर हो रही है उतनी लीव होती है. 0.5 यहाँ चलेगी, तो वहाँ कितना बचा? 1.5 एम्पियर्स यहाँ चली जाएगी. इस नोड पे देखते हैं, 1.5 एम्पियर उसकी तरफ आ रही है, 1 एम्पियर यहाँ जा रही है, तो यहाँ कितनी जानी चाहिए? 0.5. और उसी को हम वेरीफाई कर सकते हैं कि 2 and 0 पोटेंशियल डिफरेंस इज 2, रेजिस्टेंस इज 4, हायर टू लोअर एंड 0.5 एम्पियर करंट्स. This is how we calculate the currents through different conductors. This is very important as far as JEE is concerned. In next lecture, we will discuss Wheatstone bridge. With this, the resistor part of the circuit theory is complete. Now, let's try to summarize what we did in circuit theory. Point number 1, we discussed basic elements within a circuit. That is, we discussed the batteries, we discussed resistances. Then we tried to find out different value of the resistances, whether in series, whether in parallel, or the individual, you can say, resistance value of a conductor. That is R equal to rho L by A. In that, we also discussed how to find out the resistance in different scenarios, where we tried to find out the resistance where we used Ln series, where we used logarithmic different series. Then we also discussed resistance where we have to use the integration, the value of resistances in different shapes, what is the rho in the formula, how to determine rho, and whether it depends on temperature or not, its relation with the temperature. Then we discussed L, the length of the conductor, where we discussed L is a relative concept and only the direction of the current determines the value of the L. It is not the length of the conductor always, but when we say length of the current in this formula, it is actually in the direction of the current, not the actual length of the current. At times what happens, most of the times the direction of the current flows along the length of a conductor. In that case, the length of the conductor and the L in the formula will be same. But we have discussed the questions where the L and the L in the formula, they are not the same, they are different. Then we discussed the A, what the A area means, and there again we had actually we did 5 or 7 problems where we discussed the concept of this area, whether this is perpendicular to the flow of the current or there is some angle between this, how to determine this A, whether this is a absolutely, you can say, taking the area of a conductor or the perpendicular area, rather the direction of the current determines the value of the A. We already discussed it. Then we discussed the relation between or the relation of the resistance with the temperature in semiconductors and in conductors. In that specifically we discussed the formula where we used the integration and how that integration is important as far as JEE is concerned. Never ever has JEE asked to find out, you can say, the resistance of a conductor with a change, you can say, a linear variation of rho or with a linear variation of t. Always they ask the, you can say, at times the rho is, you can say, the alpha at times is variable, at times the rho is variable, at times the temperature variation is variable. So we have to make sure that we know exactly what we are doing with that formula. After that we discussed the junction law or the Kirchhoff's voltage law, but then we tried to apply it in a very different, you can say, way, and we discussed 5 types of circuits. We discussed one with the basic, you can say, requirements where we don't have to do a lot of calculations, and it was easy for us to do such questions where there's a connection between the bottom and the upper, you can say, or the left and the right through a battery. So that we discussed. Then the second type of circuit, third type of circuit, fourth type and fifth type. 5 types of circuits that are you can say, that are being asked in these exams. Later on we discussed the distribution of the currents in series and parallel. We discussed different scenarios. We discussed series parallel resistances, different cases. We discussed ladder problems and so on. And lastly we discussed the distribution of the current or the calculation of the current in different limbs in a circuit apart from the resistance part. So there are the conductors, different conductors within the circuit where we have to find out the current. So this completes a part of this current electricity chapter. Next time we will start with the Wheatstone bridge and we will move on to instruments, and we have a couple of more, you can say, insights